Dobry dzień. First, I want to thank OpenSJS for having me. I'm very flattered to be here. There are a lot of very interesting talks I've noticed, a lot of very sort of cutting-edge, helpful topics that will probably help you with your work and your projects. This talk is going to really not be helpful at all. It's mostly about fun and about exploring some interesting protocols and technologies that we can use today in the browser. So my name is George Mandis. I'm from the US. I've been a freelance web developer for over 10 years now, which in, I think, technology years is something like 350 years. You'll find all this at the end if you want to contact me about something. A couple fun facts about me. I think it's good to humanize developers a little bit. We stand up here and we say very technical things and go through our code line by line. I think it's good to remind us that we're people and we have quirky, funny things about us. So some fun facts about me. This is my first time visiting Ukraine. It's very lovely. I'm enjoying it so far. It's very warm. I'm assuming it's not this warm all the time. No? Okay. I lived as a digital nomad in 18 countries for a year once. It's kind of an interesting story. I did a 5-minute talk about that once. I was born in Saudi Arabia. That's an even longer story, but it qualifies as a fun fact, I think. And I once unintentionally cheated while I was running a marathon in North Korea. I don't really advocate cheating in general, but if you're going to cheat in a marathon, I really don't recommend doing it in that country in particular. My most known project, I was like reading the other speaker bios to see what people are affiliated with and what they're doing, and I'm always very impressed and even borderline intimidated. Because my most known project is really a very goofy project, and I don't suspect anyone has heard of it, but has anyone heard of Konami.js? Why not? There's another in the back. Okay. Well, it's my most known project, and if you're curious about it, come see my talk about it tomorrow. So before we jump into things too much, I'd like to start with an experiment, if possible. Does anyone have a laptop with them? Yeah, I see a few hands. Well, if you wouldn't mind, if you're willing to do this experiment with me, I'm going to throw a website up on the screen in a second, and you can pull it up in your browser, preferably Chrome or Firefox. It uses WebRTC, and I think those are the only two browsers that consistently use that at the moment. So there we go. I've got a website up on the screen. You wouldn't mind pulling it up. I wanted to just demonstrate some of the fun stuff I've built using MIDI and JavaScript here. Okay, well, one person's done. 2 people are on. If we get 3 or 4, there we go. Once we get 3 or 4, then it actually gets fun. And also make sure the, yes. Oh, you're right, I'm sorry. Yeah. Sure. I'll wait a moment. I was going to say, also make sure your speakers are turned up a little bit, if you don't mind. Okay. Has everyone had a chance to see that? All the people who want to participate? Yeah? All right, I'm going to go back to the other screen now here. Oops, wrong one. There we go. Okay, 7. No, let's see if that works. Whose laptop is that? Is it? Let's see. That's yours, okay. Oh, I barely hear that one. Let's see. Oh, there we go. Oh, maybe. So what's happening here is as I play different notes, they're being sent out to all of the computers that are currently connected. Oh my gosh, 12. And actually with 12, we can start doing really big intricate chords, I think. Let's see. That worked pretty well. See, like I said, nothing particularly useful. It's more like a magic show, I think. Well, and I've got one more experiment if you'll bear with me that we can try. Occasionally this one actually works. So let's see. Okay. So I've got another website I wouldn't mind if you pulled up. It's very similar to the first one, so it should be pretty easy to remember. And what's going to happen, this one's going to be a little bit different. What we're going to do is we're going to take a song, and I'm going to send a part of that song to different computers out there, and hopefully what should happen is we should get the song to, oh actually, you know what? Apologize, but I think I have to click on that before it starts working. Okay, good. So what should happen is the different parts of the song will get sent out to the different computers that are connected, and hopefully they'll play in unison and we should hear a song. So make sure your speakers are cranked up and they're a little bit quiet before. Let's see what happens here. So I'm going to go ahead and lead this box song, and let's see what happens. It's going to take a moment. Okay, so 14 seconds. It should start playing. Again, make sure your speakers are up, so let's see. 3, 2, 1. That's it. I can definitely hear that one. There's some others in there, yeah. This is where the next part comes in, I think. There we go. That worked pretty well. So I apologize. If you want to stop it, you're just going to have to close the window. I have no control over it at this point. It's just going to keep going. So we can move on here. Well, that actually worked pretty well. Thanks for indulging me on those two. So let me get to the point of my talk and what I'm going to talk about here today. So we're talking about JavaScript, obviously, given the conference is a JavaScript conference. We're talking about tiny computers, which I haven't even mentioned yet at this point. You know, I put some examples up there on the screen. I'm talking about ARDUINOs, Raspberry Pis, Esperinos. Who's heard of Esperinos? Anybody? Yeah? Yeah, I discovered those about maybe 6 months ago, and I think those are a lot of fun and really interesting. So we're going to talk about JavaScript, we're going to talk about tiny computers, and then the more interesting thing we're going to talk about is MIDI, the musical instrument device interface. Who here is familiar with MIDI, or at least thinks they're familiar with MIDI? A couple hands? Okay. Okay. So let's start with why I'm talking about JavaScript today. Obviously, JavaScript is everywhere. It's kind of become the sort of the global language of web computing. You know, for the longest time, I remember when I started 10 years ago, you pretty much only saw JavaScript in the browser on the client side. And it's amazing what's happened in 10 years. We see it everywhere. We see it on the server, we see it on the hardware level with the Esperinos. It's really the lingua franca of the web, and I think, yeah, I recently read actually that Stanford, they changed their intro to computer science course. They used to teach it using Java, and now, as of a few months ago, they're teaching it using JavaScript. One of my other jobs, besides being a freelance web developer, is I run a code boot camp, and I taught kids introductory programming, and we've used JavaScript in all those examples. It's really becoming kind of the go-to language for just at least getting your feet wet into programming. It's asynchronous nature is a very good fit with the way MIDI wants to behave. I haven't talked much about the way MIDI behaves yet, I realize, but it fits like a glove. And what's interesting about that is, for those of you that don't know what MIDI is, it's a protocol that tells electronic musical instruments how to communicate with one another. And what's interesting about that is that it was invented in 1983, so a long time ago, like before JavaScript. And when we sit down to play with MIDI in JavaScript, it just fits so naturally. It's kind of interesting. Oh, yeah, it's where the people are. That's the other reason I'm talking about JavaScript. It has, you know, the reason it's on all of our devices in all these places is because it has the community traction right now. Everyone's putting their effort on it, whether that's, you know, pushing it well beyond what it used to do with things like React and Angular and that world, or just, you know, making silly little Easter egg libraries like I'll talk about tomorrow if you come to my talk. So why am I talking about tiny computers? First of all, what am I talking about when I talk about tiny computers? I touched on this in the beginning, but I'm talking about these guys, Raspberry Pis, Arduinos, Esperinos. a little guy that I really like called the chip computer that doesn't seem to get talked about as much, but I'm really fond of those. The tiny computer movement, as I call it, really feels analogous to just the way, it's kind of the hardware complement to the way open source has blossomed over the past 20 years. I think it's really fascinating and just really empowering, and in all the ways that the platforms that we work on today are becoming more and more closed in some ways, like, you know, the infrastructure is becoming more powerful, and it's also going to silo away into fewer and fewer companies like Amazon and Facebook and Google. It's sort of inspiring to me that we can, you know, hop online and buy a $30 computer and you have access to the whole thing, and it's yours to control again. Yeah, I mean, you know, I grew up tinkering with much slower computers, and it's just interesting to see. So Arduinos, Raspberry Pis, chip computers, Esperinos. This little guy on my hand, actually, is technically an Esperino. I wrote a little JavaScript program that actually has turned this into a MIDI controller, which we'll talk about in a minute. And this is sending MIDI signals to my computer, which it's interpreting, and it's running the slideshow as we see it. I can go back, I can go forward. And also, I recognize you might not be able to see it back there, but there it is. It's a little sort of duck-shaped thing. Kind of once, twice, 3 times, like a little blue light. Anyway, just want to show that to you. The other thing that I like about tiny computers, and one of the reasons I'm sort of combining it with the other two things, I mean, to be perfectly honest, I probably could have given this talk and talked entirely about JavaScript and MIDI. That's interesting enough in its own right. But I think coupled with tiny computers, it allows for really creative applications of these two technologies. You can create standalone art projects, or sort of dip your toe into the Internet of Things and interact with hardware in a way that is sort of fun and interesting. So more than anything, they're just fun. So why MIDI? This is probably the most interesting part. Okay, so what is MIDI exactly? I only saw a few hands earlier. Some people maybe think they know, aren't quite sure. So the thing I like to, well, this is an acronym first of all, Musical Instrument Device Interface. And like I said, it's a protocol invented in 1983 that allows electronic musical instruments to talk to one another. It's a standard, very similar to the way standards are decided, like in our industry with various web standards and things. There's a body that keeps track of how MIDI works and what should be included and what shouldn't. It's also a file format. That might be the part that, depending on how old you are, I think actually like you might be more familiar with. I can remember before MP3s were a thing. For whatever reason, we would listen to like MIDI files, so I mean, kind of as a joke, but still we would download them and listen to them. And so when I was younger, I didn't really know what MIDI was exactly. I just associated it with really chintzy music, kind of like this. Fake instruments, goofy sounds, things like that. So MIDI is not this or this. Or even this. A funny aside about this one, so Brian Orr was an intern at Microsoft, and they asked him to write this song. I guess there's a really interesting blog post about it. Anyway, I'm not going to make you listen to all that. The point is, it's not chintzy musical instruments, that's its own separate thing. MIDI is a protocol. It describes how these electronic musical instruments communicate with one another. It's a standard so that they can understand different musical concepts. How many musicians are in the room? I'm curious, actually. 1, 2, okay. Okay, that's helpful, actually. Almost maybe half, I think of us. Okay. So basically, it's a just common way to describe common musical performance aspects that, if you're a musician, probably don't need a lot of explanation, but you know, when a note, basically being able to describe when a note is being played, when the note is not being played, how much velocity that note should be played with, the duration of time that the note should extend, all that kind of stuff. So MIDI, the standards maintained by the MIDI Association, like I said, those are like the major companies that oversee it. They are some of the major makers of electronic musical instruments and things. MIDI is also a file format, like I mentioned. Basically, it's a way to describe various MIDI signals in a sequence. It reminds me of this actually, of an old sort of piano roll. Has anyone ever seen these, like in real life? Not the GIF I have here, yeah. So the way those work is there are these notches cut out of the paper, and there's a mechanism inside the piano that, as it rolls, the piano will basically play itself, and where the hole shows up determines which notes are played, and how long kind of determines how long that note is played. MIDI files, although it's not a perfect analogy, I think it's a pretty good analogy. It works in my mind. And here's a visualization of a MIDI file being played. It's kind of similar when you look at it. So back to the question, why MIDI? Like I said at the top, MIDI is asynchronous, kind of like JavaScript in a way that makes it very easy to use the two at the same time. More interestingly, MIDI talks to hardware. You know, the Internet of Things is a word that gets tossed around a lot, and some of the classes I've taught to little kids involve working with Arduinos and breadboards and wiring LEDs and all that business, and basically creating these little things where you push a button and the light goes on. What's interesting to me is that we have all this hardware since 1983 that already supports this protocol that we can now start playing with and using in a way that doesn't necessarily have to be musical. And that's kind of the point of my talk today. So MIDI has obvious musical applications, but I think there are more interesting creative applications we can use MIDI for, and we're going to look at some of those today. I forgot I had other things on the slide. There we go. Also really interesting. So there are lots of packages and things that allow JavaScript on the server side to talk to MIDI these days. That's pretty easy with the C++ bindings and things like that. But Chrome speaks MIDI. This is actually really interesting. As of a couple of years ago, I think, they shipped it. And so Chrome and Chrome OS and by extension, Chromium and Electron even all support MIDI. You can plug a MIDI controller into your computer, like a keyboard or something else, and Chrome will, if you grant it permission, it will recognize the MIDI controller, and you can immediately start interacting with the page in whatever way the JavaScript decides. It's really fascinating. It's like being able to instantly basically plug in a bunch of buttons that you can suddenly use to interact with your web page. Although I realize in saying that, I kind of just described the keyboard, which doesn't sound nearly as exciting. So when I say MIDI controllers, let me just demonstrate what I'm talking about really quickly. They're the pre-existing like plug-and-play USB type, like we have here up on my screen. I don't want it to be too dark. You're not going to be able to see that. There's old hardware going back to 1983, like I said, that we can adapt and use even in Chrome. And you can build your own using tiny computers and Arduinos. I actually have one at home that broke, sadly. I don't have with me today. But you can build your own MIDI controllers surprisingly easily and interact with things in an interesting way. So here's a synthesizer keyboard. This is actually the first one that supported MIDI back in I guess that came out in 83, I'm pretty sure. This is an LPDA. I actually have one of these up here. I'm going to be using that for some of my demos today. This is a foot controller. I've actually got this one right down here too. It's you just stomp on it and it can send MIDI signals to things. Oh, I didn't plug it in. I knew I forgot something. Well, I'm going to have to plug it in a minute. Okay. And then there are other, so most of them boil down to just things with buttons and knobs and sliders and whatnot, and there are other more interesting types. There are MIDI controllers that have accelerometers, kind of like the one that's in your phone. There are breath-controlled ones that react to how strongly you breathe into them. And there are other more kind of abstract, hard to explain ones too. I have a little website set up that links to these if you're curious later and want to talk to me about it. Like I said earlier, you can build your own. That's really kind of interesting. It's like, you know, I know that some of the protocols involved with the Internet of Things are sort of nascent and being figured out, and it will do much more complicated things than MIDI was ever intended to do. But what's fun about MIDI is that it is mature and it works today, and you can build something that speaks MIDI very easily. And because it's so simple and because it's not going to break, you can get up and running and build something kind of interesting without a lot of fuss. Yeah, this is the one I had at home that broke. I just had a little video, thankfully, sort of demonstrating what that does. It was intended to be a musical instrument, but I just made a little demo that lights up some squares on the screen. I can click, and they go off on the device. It's a two-way communication protocol. That's the other fun part. So when I hit the buttons, it's talking to my computer, obviously, and then when I click on the actual when I click on the squares on the screen, it's talking back to the MIDI controller, and as you saw a moment ago, the lights go off. I'll be quick about this one, but a MIDI message has 3 bytes. 2 of those are, there are only 2 different types. They're the status messages and the data messages. The data messages are the things that actually tell you where the notes are being played. A status byte always begins with a 1, data bytes always begin with a 0, that leaves 7 bits left per byte for expressing the message. What you really need to know is that basically when it's all said and done, it boils down to you get 3 numbers. You hit a button on the device and you get 3 numbers, and you get to decide how that gets interpreted. And here's an example of those 3 numbers as they are usually represented. That's an example of just a basic note on message. And then that probably looks familiar to you now. Just a basic array with 3 numbers, because at the end of the day, when we finally get this message back in JavaScript, that's what it's going to look like. And again, getting back to the MIDI standard thing, this is how all those different numbers, what they're supposed to mean. None of this is particularly important to you, but it's just worth it showing that someone sat down and decided that we need something to explain what a pitch bend does, or like which number range should be used to represent both controllers and things like that. So okay, what does using JavaScript and MIDI look like? This is interesting and I think kind of helpful. So, who's familiar with using like the camera and geolocation in the browser? Or anything like that? Basically anything where you have to ask for permission from the user. Usually like you go to the website, say, hey, this website wants to know your location, or this website wants to use your camera, or some such thing. Well, if you're using Chrome, way down at the bottom there's one that says MIDI devices, which I don't think, unless you're looking for it, anyone even knows they're there. So it's structured almost exactly like any of these other sort of permission-based features that you use in Chrome. And so it doesn't look all that dissimilar to requesting location in some ways. You request MIDI access, it returns a promise. You pass 2 functions as arguments to that. And the first one says, well, if it's successful, hey, now we got a MIDI access object and we can start doing things with it. And if it's not, that means they rejected it, because I don't know what scenario that would really arise, where someone has like a MIDI keyboard plugged in and they arrive on the website and it's asking to use it and they don't want to. But I guess that covers that scenario. Right, so then if you successfully connect your MIDI device, now you can iterate through all of the devices that are actually plugged in to the machine. In this sort of like pseudocode example I'm showing how I've actually structured part of my slides up here. So I have something that, I've already given my set permission to access all my MIDI controllers. It goes through all the controllers that are plugged in, it looks for them by name, and then it sort of sections them off because I have specific functions set up to handle the way each of these different controllers up here interacts with my slideshow and some of the demos that I'm going to show you. Right, and then getting back to what I said earlier about the anatomy of the MIDI message and how it boils down to 3 numbers. So once we actually break down that function that we passed as the argument to the controller, which we identified it, like I said, it just comes down to 3 numbers. We get an array of 3 numbers, and exactly what you want to do with that really depends on the device. And I have a demo that I'll show you in a little bit. It sort of touches on that. But basically, unless the device is, depending on how well documented the device is, you're probably going to end up doing a lot of guesswork. when I get a new MIDI device and I start playing around with it, the first thing I do is I plug it in, I pull up my script that just starts spitting out numbers at me, and I hit all the buttons and I just see which numbers are changing. And then I slowly start to get a sense of like which numbers are being used to represent what on the device. And from there, I can extend it to do something more interesting with whatever I'm building. There are libraries that make this a little bit easier, but not really all that different. There's one called WebMIDI.js that I use quite a bit. It makes more sense in the context of doing musical things. Basically, all it does is instead of saying, hey, I want to listen for a MIDI event and I just want the raw numbers, it's going to say, hey, I'm listening for a MIDI event and I'm listening for this kind of event. And you use a musical, use one of the MIDI standard descriptions to say what you're listening for. Like in this case, you're listening for a note on event. You could just as well be listening for when a note goes off and have something triggered that way. Oh yeah, and then MIDI utils.js. This is just a very convenient tool for converting notes to frequencies to MIDI notes. And again, if you're doing a more musical application, this can come in very handy sometimes. And that's basically it as far as like getting JavaScript to work in your browser. It's really not that hard. That's 90% of it. You request permission, you set up the listeners, and you get 3 numbers back. On the server side, it's not that different. There are a few differences, but all in all, it's not that different. One of the differences is we don't need to request permission, obviously, because we're on the browser. We kind of have access to the, whatever permission level of the user that's running the script in this case. Latency can be more of an issue or less of an issue depending on what you're trying to achieve. I can talk about that a little bit later. If you want to work with MIDI files, it's probably a better choice. There are more packages available in Node to do that. It's not really something you can do very directly in the browser. And what's kind of cool is a lot of the front-end libraries, like the 2 that I mentioned earlier, just one, MIDI utils.js, that also works with Node. So the basic setup for listening to and talking to a MIDI device on the server is something like this. It's actually a little bit more straightforward in some ways because we don't have to ask for permission and deal with that. So basically we include the MIDI package, we create a new input object, we listen for any kind of message from that object, and then we get 2 variables returned. Now we get message, which is those 3 numbers I talked about earlier, and then a different variable called delta time, which just tells you how much time has transpired since the last time a message came in. And that's it. That's really 99% of it right there. So I'm starting to delve into the demo segment of my talk here. So I have a whole series of demos that are, like I said at the beginning, like non-musical demos with MIDI, which I think are more interesting. But I wanted to also start off with some more musical demos, since this is, I think in some ways, can better explain what the devices are designed to do and how they're set up here. Let's see. So what I'm probably going to do is run through a couple of these demos, and then we might take a coffee break, and then for part 2, I'll run through the remainder of my demos, just to give you guys a heads up for how this is going to go. So, okay, this is actually really good. So when I said earlier, when I get a new MIDI device, one of the first things I do is I plug it in and I just see what all the numbers do. So here's a little mock-up of literally kind of what I do. So I'm going to click on this link. And right now, those are all the MIDI devices that are plugged into my machine. So it's telling me it found all those controllers. What's kind of nice is the way the hardware is designed, it actually stores the name of the device on the device, and so you get that information back. And so now, if I'm looking at this controller right here, which I recognize you can't see, but it's just a grid of squares, and I want to see what signals do I get when I hit this button up here. Oh, there we go. So when I push down, I get those 3 numbers, and when I lift up, I get those 3 numbers. So as I start playing with it, and I start going down the line, I can start to recognize patterns, and I see pretty quickly, oh, okay, so that second number is changing every time I move over to the next square, so it's sort of analogous to the column, perhaps, in this case. And when I push down, I get 127 on that far right number, and when I lift up, I get a 0. So that's basically telling me whether it's on or off. That's pretty easy. And basically, that's just the kind of exploration I end up going through. Sometimes you get more interesting things. I'm turning a knob right now on one of my controllers up here, and you can see that, oh, well, the right number is obviously telling me, you know, where the knob is set to at the moment. And if I go to the next knob in the row, that second number goes up. So I can figure out pretty quickly, well, oh, okay, so that second number is going to correlate to which knob I'm talking about, and the third number is going to tell me where that knob is set. It's really not rocket science. It's pretty straightforward. It's just a matter of being patient and then finding interesting, kind of creative ways, I think, to apply this to stuff. Okay, and okay, so here's a good simple musical example. Kind of like what I did at the top of the talk with all your computers in that interactive segment. But I have a little keyboard up here. I know you can't really see it, but so, I mean, that's just a very simple, it's using the web audio API, which is going to be an interesting talk about that tomorrow, I believe. But basically, I use the web MIDI JS library to map those MIDI signals and convert them to frequencies to be able to talk to the web audio API and create those sounds. And here's one more audio demo, and then I think we're going to call it for this portion of the talk. And then if you want to come back to phase 2, I have some more interesting non-musical things we can do. And so here's my last web audio demo, featuring just a couple other things you can do with MIDI controllers. Okay. So right now I triggered an audio file, which is playing, which you can kind of hear a little bit. And then I can turn one of these knobs and play the pitch. Play the pitch in a more subtle way. And then maybe I can reverse it. I mean, really most of the magic that's happening with this demo is with the web audio API. It sounds really cool. There's a cool visualization going on in the background. But by mapping these different controls to a MIDI controller in a custom way, having a new way of interacting with it, it's kind of interesting. In particular, the ability to change the speed. And other things, the way that maps very nicely to a knob kind of interface. It's kind of interesting. I never made a stop button for this demo, I'm not realizing. And again, this is the demo we had at the top of the talk, the interactive piano recital, where each individual note was getting thrown out to the people in the audience. Again, what I was doing is I was just playing the notes up here on my MIDI controller, and I was using WebRTC to create a peer-to-peer connection with each of you and to send out those notes individually and create kind of an interesting symphony effect. Okay. I'm going to call it here before moving on to the rest of the demos, I think, so we can take like a 10-minute coffee break. And yeah. Okay.
Cool. Yeah. You're ready as well, right?
I'm mostly ready.
Okay, that's great. For none of the lights, I'm about to proceed.
I'm assuming no one just walked in for the second part and skipped the first part. Did anyone not see the first part? Oh, one person did. Okay, 2, 3, okay. Well, I apologize for saying that. Well, part of me wants to show this demo again, just because I want everyone to see it. So we left off here. I was talking about the musical demos, the musical applications of MIDI, which are the more common and the well-known ones, and I wanted to transition from that into basically leveraging these MIDI controllers in ways that are totally non-musical and interesting, and talk about what that means. So here is the interactive piano recital one that we talked about. Like I mentioned right before the break, that used WebRTC to create peer-to-peer connections with each computer. As I played the notes on the piano, it sent out the notes to each of you, and because you had the page up in your browser, it used the Web Audio API to generate a sine wave. And we got sort of a nice sound. The second demo that we did at the top of the talk was a little bit different. It chopped up a MIDI file, it chopped up a box song, and it sent different parts of that box song out to each of you. And the idea was that I was supposed to play in unison, in symphony. One of the questions I got just a moment ago when we were having coffee was, is JavaScript like a, basically JavaScript has latency problems. When you're trying to be very precise with music, JavaScript is not necessarily a great choice for a bunch of reasons. And that's definitely true. I mean, one of the reasons I used WebRTC and not WebSockets on the first example with the piano was the latency was just too unpredictable. When I tested a lot at home, I really wanted the WebSockets to work just because it works on a greater variety of devices. I was able to get it to work on iPads and all that. But it was just too much latency. It didn't work very well. With this one, I came up with a little trick. I realized that, well, if I send out all of the parts of a MIDI file to each individual computer, there's no sense, I don't know when each computer is going to download the part. Each one's going to take a different amount of time, and I need to find out a way when they're all finished. And so I came up with a scheme where, instead of waiting for them to let me know that they're done, I'm just going to send, along with the information from the MIDI file, I'm going to send a very precise date out in the future, like a very precise Unix timestamp that's about 20 seconds in the future. And my assumption is, well, 20 seconds should be enough. And if 20 seconds isn't enough, then the script is going to not let them play their part. But hopefully in those 20 seconds, they can download the part. And they'll also be aware of the precise Unix timestamp that they're supposed to start playing the song. And it's a little bit of a gamble on my part, but I'm just going to assume in this day and age, because every computer for the most part, syncs their clock to a web server somewhere else, that everyone's time on their computer would be close enough that they would all start about the same time. And all the times I've tested that, it mostly works out. So the latency issues, you have to find weird, clever ways to get around it at this point. Okay, so now let's look at, part of the title of my talk, the more than music stuff. One of someone pointed out to me, is everyone familiar with the Microsoft Dial interface? I think that's what it's called. It's that big cylindrical thing you can put on the surface. And yeah, I think that's what it's called. Someone pointed out to me this demo that I made. Basically, it's just a color mixer using the different knobs and the controllers here on the screen, on the controller. Let me demonstrate that here. Oh, it's a very dark screen up there. I don't know if you can see that. Oh, there we go. So now I can use these knobs and controllers to sort of precisely mix different shades here. There we go. Now I can get some of my blue in there. Or my green, sorry. And now I'll add some blue. And again, it's not a earth-shattering kind of demo, but it's an example of repurposing something that is a musical instrument sitting on my desk in a way that was not necessarily intended, in a way that could potentially be useful if I was to build a sort of interface where I maybe had precisely mixed colors, or another demo I was working on is precisely mixing and fine-tuning different CSS attributes so that a page, or not a page, elements in the DOM. So this demo that I'm about to show you what you're looking at right here, I made this a few years ago when Alexei asked me like what was my inspiration for this whole project, and I don't know if you heard or all of you were in the room, but I'm a musician, and I was using a piece of software called Mainstage by Apple, and I was using that to trigger sounds and to add effects to my guitar as I was playing. It was kind of interesting. One of the features of Apple Mainstage is you can use JavaScript to script things and to interact with the MIDI components built into that software. I couldn't get it to do what I wanted to do exactly, so I found a node package that let me interact with MIDI and by that extension talk to Mainstage. And because I could write the script entirely myself and I didn't have weird rules that I had to follow like with the Mainstage scripting, I could just make it do exactly what I wanted, and I realized in doing that, oh hey, I can have these MIDI controllers do anything that I want. And so one of the things I did, it was still sort of related to music, but we're starting to transition now into some non-musical things, is I talked to my friend I play music with, we were in a duo, and I said, what if we had some visuals behind us when we played? What if we made some weird art stuff? And so we came up with this thing that basically took random old movies and would also take random old books, and it would take snippets from those books and create random poetry from those books and just overlay it on top of the movies as they played in totally random combinations. And we called it the poetry box. We only used it like twice, but it was kind of interesting. And this was the interactive art project that ultimately inspired me to kind of pursue some of these other things and come and give this talk today. So I recreated it just to sort of demonstrate what that's like. It's kind of interesting. I find randomness in our projects to be really intriguing sometimes. So let's see. Trigger that, and I think if it hits this guy, there we go, I get a random poem. So what it's doing is it's using, who's familiar with Gutenberg.org, the Gutenberg project? Anybody? It might be a very American thing, I'm now realizing, but it's supposed to, they take, what's the word, public domain books and make them freely available, especially old classic books, and those might be old classic like American books, I now realize. But basically I downloaded a bunch of these old classic books and we chopped them up sentence by sentence and we randomly restructure them. So every time I hit this button, it takes a new book and it creates a random poem. Just pulling random sentences out of a book. It pulls a random sentence to create the title, and then 3 more random sentences to create the rest of the poem. And usually it's nonsense, it doesn't make sense, but sometimes when you combine it with some kind of random visual in the background, it starts to like almost take on weird meaning. It's really interesting. We spend a lot of time just like hitting the buttons and watching it, you know? We spend way too much time just watching this and coming up with random poems and scenes. And this is playing in the background while we play our music, and I think people probably found this a lot more interesting than our actual music, to be honest. And just to give like the full experience, because you know I'm not up here playing guitar and stuff with my friend, I hit this button here, and it's going to pull some random sound. I think some random piece of music should start playing. And this project is exactly the kind of thing, getting back to the top of the talk when I mentioned tiny computers, I originally had this running on a Raspberry Pi, and it was a self-contained little art project. I would just hit these buttons and it would create random poems and random scenes, and it was a lot of fun. So this was the very first project I built using MIDI and JavaScript that kind of inspired me to see what else I could build. I'm going to do one more just because I like this too much. I've already popular. Let's see if we can get one more video. Anyway, you get the idea. It kind of just goes on like this, but it's a little bit of fun. Oh, and the other part I didn't mention is we had a projector. So it was, what you're seeing there is like projected on the wall, and I think it's a little bit more fun when it's kind of like that. Oh, I guess it's being projected now, didn't it? So that was the original project that sort of inspired it, and this, I just explained what it did. It takes 4 random movies from archive.org. Who's familiar with archive.org? Okay, more people on that. And like I said, it would just create random poems by taking random sentences from the same book and chopping. Oh, what's interesting in that approach is and I'm getting totally off topic, but what's interesting with that approach is we found that if you take random sentences from the same book, because it's written by the same author and it has the same voice, the poems that you generate are going to be a lot more, they go together much better, we found, than if you just take completely random sentences from all over the place. Okay. This might be another very American thing, I'm very curious. Who's familiar with the movie The Goonies? Oh, that's one of you. Well, I think if you're an American of my age, you probably love this movie. So there is a scene, and this movie is about a bunch of children who are trying to escape from bad guys, and they end up finding pirate treasure that's covered in a bunch of booby traps. So they have to escape these very elaborate traps, and it's just a really fun, goofy movie. So there was a scene in that movie where they have to play an organ that is made out of a skeleton. And they have to play the organ correctly so that the door can open, otherwise they're going to get caught by the bad guys. So there's one of the lead actresses trying to read the sheet music and figure out how to play on the organ. And they're looking at the sheet music, trying to figure out what notes they're supposed to play. And I don't know why my mind went here, but I thought, I wonder if we could build this, in real life. And I hate to disappoint you, I have not built this yet. It's on my list. I still haven't figured out where to get all the bones, where to get the skeletons, that's the hardest part. So could we make something like that? Kind of. So what I have up here is a demo that sort of simulates it to some degree. Let's take a quick look. And so what it's doing, you can see down here, the musicians in the audience may be able to recognize the notes. It's telling me a random chord that I'm supposed to play. And I'm a really terrible sight reader, so it takes me a minute to do that. Oh God, that's awful. Oh. Well, basically, I made a little game, and if oh, here we go. So I go D sharp, F, and G sharp, There we go, I got one right. Now if I do the next one, C. There we go. Finally. Anyway, so that was my sort of proof of concept, exploring the same idea that I saw in that goofy movie. And then I thought, oh, can we make a real one? And I don't mean real, real skeleton necessarily, but a real world device where, if I'm playing on a much larger keyboard, could we have it trigger motors and servos and things and actually open a door? And, I haven't built it yet, and if I did, I couldn't bring it with me on these talks, but I just wanted to show a couple videos out there. If you Google MIDI stepper motors, you can find, basically what I'm about to show you is a bunch of motors that are being interacted with using MIDI protocol. There we go. So this guy's got a bunch of tiny computers in his box, a bunch of wires connected to these motors, and MIDI signals right now are communicating with it and triggering voltages to make the things turn. And I looked at enough of these, and I looked at the code, and I thought, if I had a spare weekend or two, I probably could build something that is a little bit like that Goonies bridge. And this one actually looks a little bit more like my setup. Oops, I did the wrong one. There we go. And this one's a little more clear and easy to see. So I'm sure with some time, maybe hopefully one of these days I'll come back and I'll have a video of something I actually built at home in my backyard where I'm playing an organ. Okay, going on to some other demos I built. This is sort of similar to the color mixer in the beginning, but I really enjoy playing with CSS filters. It's kind of like having Photoshop on your website sometimes. There are so many knobs on this little controller I have up here. I thought it might be kind of fun to map those to some of my favorite CSS filters, so I could just sort of play these things in real time. Let's see. Oh, I have to trigger this correctly. There we go. So now I can kind of play with the contrast. Oops. Play with the brightness. But those aren't as much fun as like playing with the sepia and some of the other more interesting filters here. It's just kind of a different way of interacting with these numbers and these attributes. You know, if you're like me, I spend so much time in front of the computer, like I kind of just think in terms of numbers. Like when I think about the color I want to make something, or I think about a particular quality I want to give to something using CSS, it just pops in my head as a number. Like I don't even I don't see the color orange. I see the number first, and then eventually it becomes orange. This kind of takes the numbers away from it. It's kind of nice to be able to just use these knobs and sort of mix it in a way that I find interesting without focusing too much on, you know, am I at 75% or 76% or what's going on exactly. Oops. Anyway, so that was kind of a fun demo. The next extension of this one I'm hoping to build is I want something where I can actually click on the individual elements within the page and interact with the various CSS properties, sort of like through the web inspector. MIDI pixel art. This one is using, you guys can't really see it, let's see. So I've got this grid of buttons up here. You can kind of see it. And this is called the Innovation LAUNCHPAD. It's a very popular USB MIDI controller for DJs and electronic musicians and things like this. This is a very cheap one I bought off some kid for like $20 on Craigslist. And we're going to use it to just basically draw pictures. These also make a really great device for MIDI experimentation in this context because it's just a grid of buttons. You can do a lot with the grid. Let's see. Do this. Oops. And just to demonstrate again, let's see. Because I know you can't see what I'm interacting with up here. That's what it looks like down here on my desk right now. Oops. And this one I have is so basic, it only does 2 different colors, but I have a fancier one at home that does a lot of different colors, and I'm working on adapting that to this because I think it'd be a lot of fun. Oh yeah, I made a note about this. So all the other ones I was using a library just to sort of make the detecting of what notes were being broadcast a little bit easier and more straightforward. With this one, I used the native web MIDI implementation, which I showed at the beginning of phase 1. Just because because of the layout, because it's an 8x8 grid, I can do some bit shifting that makes it much easier to translate that to just a basic like XY axis. If you want to see the code later, I'll put it up on GitHub. It's kind of interesting. It's the other thing I talked about during the first part of this talk was there are lots of different kinds of MIDI controllers. We have most of them just boil down to having buttons and knobs, but they're breath controllers, they're accelerometers, there's some other interesting things. So this thing I'm wearing in my hand, it's glowing, you might have noticed. This is a MIDI accelerometer controller. So it sends out 3 different MIDI signals depending on the orientation of my hand. To be perfectly honest, I haven't really figured it out in some ways, like I kind of contort my body in a funny way. And if I was trying to actually make music with this, I think it'd be a lost cause. But it's a really cool tool for doing weird experimental, interesting things on the web browser. So we're going to take a look at a color mixer that I made, which is pretty straightforward. So if I hold my hand straight out, I've got sort of this purple color. You can see, basically I mapped those 3 different MIDI signals I was talking about to the RGB values, which you can see changing up at the top. So now if I move my hand to the right, it's more of a dark purple kind of color. If I move to the left, it gets lighter, kind of a green. If I tilt it back towards me, we get this nice rich blue. Or like purple, I guess I'd probably do something like, something like this. Yeah, it's just kind of an interesting, fun way to interact with things. I feel like this could be a good interface for some sort of interactive art exhibit or something like that. Oh, that's right. The other thing I did was like, when I find a shape that I really like, it'd be nice if I could just like save it. Okay, so there's color 1. It's kind of nice color 2. Because my other thought was like, well, maybe this could be a way of like just taking a palette for something and then saving the codes down there. It's like my CSS. The only problem is with some colors, you have to like, contort your hand into impossible shapes, so I just take it off and I move it around sometimes. Let's see if I can get like a red color. Oh, there we go. That's a red. That'll work. Anyway, so that was kind of a fun one to build. I'm going to hurry through these next ones here so I can have a few minutes for questions, hopefully. So the other one I built is this. I realized, how can I turn that into a game? I really like to turn things into games, not so much because I honestly play that many games, but I feel like building games is a really good way to learn different concepts. And so I took that same thing we just did and I made this thing. And basically I'm trying to match the color down there. And once I get it, let's see. Sometimes, and once we match it, we'll know because it tells me. Let's see. Oh, come on. To be honest, the other thing you can do, you just kind of do this. And sometimes we'll just get it. There we go. Oops. There we go. Anyway, so that was kind of a fun thing to build. I don't know how good of a game that actually is, but it was an interesting thought exercise. Okay. And then while I was on the topic of building games, I was thinking about what other kinds of games could I build, just looking at the way these controllers are laid out here. And I don't know if you remember the picture of the old pink V8 at the top of the first one. I don't know if you can really see it very well, but there are basically 4 buttons on this controller, or sorry, 8. There's 2 rows of 4. And I was staring at that and I was thinking like, how did I turn that into a game? And then I remembered, does anyone know what whack-a-mole is? Does that translate? I don't know, you're gonna see, you're gonna laugh, I think. So I thought, well maybe, these can detect velocity. It's not just on or off of these, it detects how hard I hit them too. So maybe I could turn that into some kind of a game. And so I made, oops. Oh, I missed. Let's save it again. Oh, there we go. Finally. Actually, for some reason, it's not working as well as it did before. I'm not sure why. Anyway, I made this really goofy game where the moles just keep popping up and eventually you get them. And because of the velocity detection, I realized we could have a stat called confidence, and we'll measure how hard I'm hitting it. Whether I'm really confident about whacking those moles or I'm just kind of like tepidly tapping at them. So that was kind of a goofy game I made using a MIDI controller. And then this is like my favorite one. So who plays Go? Anyone familiar with that game? Yeah? Okay. So I was looking at the LAUNCHPAD here, and thought maybe we can turn this into an interactive game of Go. So let's see this here. Well, it's not going to totally fit on the screen, but... So now we can actually play an interactive game of Go, taking turns. Instead of black and white, we have red and green. I'm a very terrible Go player, so bear with me for a minute. Okay, this and that, and this, that, this, and then I think that one should disappear. Oh, there we go. There we go. And what's cool about this project is you could adapt this pretty easily to live on a tiny computer and basically glue it to the back of a LAUNCHPAD, add a battery, and now you have this like self-contained interactive Go game, which is kind of strange, but I think that's cool. There's something kind of fun about that. And so that's kind of the end of my talk here. I have this scene I like to include at the end. This is up in Seattle, Washington, which is close to where I'm sort of close to where I'm from. And they have this exhibit outside of the Experience Music Center there. And it's a giant interactive musical program, basically, built using totally non-musical things. There's, as you can see, billiard balls and giant industrial tubes and metal bars running through them. And it creates a scale, and you can interact with it, and it's a lot of fun. And I just really enjoy things like that. And it made me think about, you know, I've seen similar sort of installations here and there. And I really like it when people take non-musical things and repurpose them for musical applications. And sort of in that vein, the way that these things are repurposed for music, I think it's interesting to repurpose musical things like MIDI for more creative and interesting pursuits. Спасибо.